Alright, I'm going to explain how to use Google Docs spreadsheets to just do a quick and easy graph, and you'll be able to do this for the rest of your life. It's very similar to Excel, for those of you who know Excel very well. This is going to end up being your x-axis, and this is going to end up being your y-axis. So you just simply put the data in there. You don't need any units, titles, anything, just the numbers. The units can go in later. And all you do is simply highlight that, and you can either click this button, which is Insert Chart, or you can do Insert Chart here, and that's what we want, is a chart. So either one works. I'll do that. And so we don't want any of these things actually, just for a regular old graph. These are bar graphs. So if you go to Charts, and then we want a scatter plot, that just simply plots the data, something simple like that. Click on that, and there it is. Boom. Alright, so that's the basic chart there. So we want to customize it to title it and things. So you click over here to customize, and we can give it a title. I just made this up, so I'll just make something up here. We'll say force of gravity as a function of distance. This is sort of the convention now. This as a function of that. So the force of gravity, which is your dependent variable on the y-axis, as a function of x, the distance from the center of the Earth, let's say in this case. So then we can mess around with some things there. I don't want to change too much. We can italicize it, I suppose. I don't really care about any of that. This, for some reason, and I don't know why, this little legend shows up here, and this is how you get rid of it. This little blue dot over here is a legend. So we just click none, and that goes away. You can change the font if you care. Who cares? You can give it a funky background, but that's usually unnecessary. Here we can label the axes. So the horizontal axes here would be, in this case, let's see, the force of gravity, which is our independent variable. So I'll just say force of gravity in units of newtons. Now this is important. It doesn't always give you origin at 0. Sometimes it starts at 15. That really distorts things, particularly in your all's lab. So it's important you put in a minimum of 0 there, so make sure it starts at the origin. Okay, so then the vertical axis, I click here to get the vertical axis, and I want to call that force of gravity. Switch them. This is force of gravity in newtons. Yeah, so I accidentally switched those. My horizontal should be distance. Distance, let's say in kilometers. All right. That's about it. We can mess with grid lines and all that, but I usually don't mess with that. And we're pretty much done. You can change the point size there if you don't like how big and fat those are, but not much else to do here. That's a pretty good graph right there. So we just click Insert, and there we go. At this point, we can go up here and click Print. Print the current sheet. And I guess it makes it into a PDF here. So nope, we don't want all these numbers up here, so we don't want that. Alright, so the way to print it without getting all the numbers in the background, just click on the graph here, and there's a little menu up here, and just save it, and it'll save it as an image, like a JPEG or something like that. And there it is. Then you can do File, copy it to Word if you want to put it into a formal Word document or something like that, or you can just print it off right there. That's pretty much how you do it. If you decide that you don't really particularly like something about it, you don't have to start all over again. You can just click on here, and a lot of the edit stuff is right there. Background color, background, like that, quick edit mode. There. Now, when you guys, I think one of your graphs tends to look like this. For some reason, it's human nature to make everything want to be a straight line. The one thing that Google Docs doesn't do is it doesn't make a best fit line. And a best fit line you'll just have to do in pencil after you print it off. So you want to make a line that's the best fit. You don't just connect the dots. But this looks like an inverse relationship of some sort. So I would want to draw a curve nice and smoothly and have roughly the same number of dots, the data points, on either side of that curve. That's how you do a best fit line. Obviously it doesn't make any sense to make a straight line linear proportionality, because the proportionality looks like an inverse square relationship, if anything. Now, what should you be expecting in your lab as a result? Well, here's the situation, right, that we had. We have the tension as you swung. This is the stopper right here. As this swung around in a circle, like that, there's tension, that's the centripetal force, but that tension, even though it is an internal force to the system, this tension pulling on the stopper should be the tension upward on the hanging mass, and this tension should equal the weight of the hanging mass. So since the net force is tension on the stopper, and that equals m2g, then that should also equal the net centripetal force on the stopper, which is mv squared over r. That's m1. m1 is the mass of the stopper, right? So this is the relationships here, and what we tested in this lab is all the effects on v. So if you solve that equation for v, we see that v, if we solve that, would equal what? Should equal the square root of m2gr over m1. Okay, so then proportionally, then how should everything work out? So that means the speed, that's what we kept measuring. Technically we measured the period, we converted that into the speed. The speed should be directly proportional to m2g, which is the weight of the hanging mass. It should be the square root of that, and it should be directly proportional to the square root of radius, which we also varied, and it should be inversely proportional to the root of the stopper mass. So those are our three independent variables. That's what we did. So I want you to figure out what should that look like, what should that look like, and what should that look like as a curve. What does a root curve look like, and what does an inverse root curve look like? And then take a look at your data and graph it and see how close you get.